Hello and welcome to Chapter 10, Section 5, which is on surface area of pyramids. This is going to start on textbook page 783 and go through textbook page 786. So as usual, you're going to need your pencil with an eraser for the on your own problems. In the top right corner, you'll see that you need lined paper. So you want to make sure to go ahead and take that out now if you don't have it. You also want to have your colored pencils out so that you can make sure that you identify each one of the different faces for the pyramid. All right, let's go ahead and get started. You should now be looking at textbook page 783. You see the little painter guy there on the bottom. And at the top, it says, scan the lesson, predict 2 things you will learn about finding the surface area of pyramids. So the first thing that you're going to learn is how to use a net to find surface area of a pyramid. And the next thing that you're going to learn is how to use area formulas to find the surface area of a pyramid. All right, so now you also want to write at the bottom or off to the side that you're going to show the net or you're going to show the formulas that you use. So that's the 2 different things that you're going to be working on, so you want to make sure that you're using those 2 different things. The next piece under the vocabulary startup says a pyramid is a 3-dimensional figure with at least 3 triangular sides. You can see that I put a question mark above at least because that's saying that there could be more. That meet at a common vertex, so the sides all meet at a common vertex and only have one base that is a polygon. The triangular sides of a square pyramid are called the lateral faces. So I went ahead and underlined vertex in the blue, and then I pointed to the vertex and wrote vertex in the word bank, or the word block there. Then I went ahead and put a box around the base of the square pyramid. I would like you to do the same thing. Go ahead and outline the base of the square pyramid. And even though there's not a box for it, go ahead and write the word base so that you know which one is the base. The triangular sides of a square pyramid are called lateral faces. So I went ahead and showed you the lateral face and I outlined it in purple. And I went ahead and labeled the pyramid at the top, so you want to do the same thing. Then it says the slant height is the height of each lateral face. So you can see that is outlined with that pink dotted line, and it's also got the perpendicular sign at the bottom. And so you want to be sure that you know the key terms that are listed here and that you're able to identify each piece. All right, so notice too that I put an orange box around only one base. And that's because unlike the rectangular prism and the triangular prism that both have 2 bases, the pyramid only has 1 base. So now you're looking at the real world link. It says Claude made a model of the large pyramid in front of the Louvre Museum. His model is shown. Draw the faces of the pyramid. So the base is going to be what looks like a square. And I know this because it's 5 inches by 5 inches. So you can see that right here, 5 inches by 5 inches. And then I'm going to draw the triangles as purple, and you can see that they have a height of 3.5 inches, which is right here, and a base of 5 inches. So you can see that we have to draw each one of those, and you also want to notice that you have 4 sides because you have 4 triangles because you have 4 sides on the base. So you'll be able to tell how many triangular lateral faces you have based on how many sides your base has. So because this square has 4 sides, you have 4 triangular lateral faces. All right, let's go ahead and look at textbook page 784. At the top of 784, you'll see it says surface area of pyramids, and you can see that they have a net. And again, the net is when the shape has been broken apart, so to speak. It says the surface area of the surface area of a pyramid is the sum of the area of the base and the area of the lateral faces. So some pyramids have square or rectangular bases. You can use a net to find the surface area of a pyramid. So I've circled the word net, and I went ahead and drew an arrow to the net that you see here. All right, so now we're looking at example 1. Just like before when we worked on the rectangular prism and the triangular prism, I'm going to ask you to start with the base. But unlike those other 2 prisms, this one only has 1 base, so you want to remember that. So I have first started by drawing the figure here. Now I just drew it as a box to begin with because I don't know what the dimensions are. But a closer look, you can see the that the dimensions are 7 centimeters and 7 centimeters. So that makes this a square, a square for the base. So because it's a square, I'm going to label it as a square, and you can use the formula for area as length times width, or you can use area equals side squared. Technically, area equals side squared is the correct formula, but length times width works as well. From there, you want to plug in the 7 and the 7, so you get an area of 49. I did put a box around the 49, just like I did when we were working with the triangular and rectangular prisms, and I'm also going to, a little bit further down the slide, I'm going to go ahead and write the number 1 and circle it there so that I can identify that this is my first face. That will be just a little bit later on in this slide. So now I'm going to identify the triangle. As you can see, I went ahead and drew a green outline around the triangle, one of the triangular faces. As you can see, each of the triangular faces is going to have a base of 7 and a height of 9. So I went ahead and just made a little sketch diagram of it. I'm sort of running out of space here, so I'm going to go over to the right-hand side in just a moment. So then I fill in my formula, area equals base times height divided by 2, and I fill in 7 times 9 divided by 2, and I get 63 divided by 2, which is going to give me 31.5. And I could do that in my head, so I anticipate that you probably could as well. As promised, later on in the slide, you see that we have the 1 circled up there where the square is, because that's our first face. That's the base of the pyramid, but that's the first thing that we need to count as area. As you can also see, for the triangle of the lateral face, we have 31.5. I went ahead and put a box around that, so you should as well. And then I'm going to circle 2, 3, 4, and 5. The reason I'm circling 2, 3, 4, and 5 is because that accounts for this one, this one, this one, and this one. So that's how I know that I have all 4 of the triangular lateral faces. So from here, you're going to go ahead and find the surface area by adding up 49, which was the 1 square base, plus 31.5, plus 31.5, plus 31.5, plus 31.5. Notice you want to make sure, and this has been for all 3 of these different types of prisms, you want to make sure, and actually this is a pyramid, but you want to make sure that you line up the decimal properly. So you can see that in pink, I went ahead and added a decimal and a 0, and then I finished adding. So I get 175 square centimeters or centimeters squared. So you should have the same thing written on your paper. All right, let's go ahead and look at the on your own problem for A. So for A, you want to do the on your own in pencil only. So go ahead and pause the video now and do that now. All right, welcome back. Let's go ahead and see what you have. So I'm going to start with the base. I put a yellow yellow outline around the base. As you can see, this is a square base, 16 by 16. So that makes our life a little bit easier. So I'm going to label it as 16 by 16, and I'm going to use the correct formula, which is area equals side squared. You do have a little bit of math involved here, so you want to make sure that you get area equals 256. All right, from there, you want to go ahead and put a box around the 250. Whoa, just kidding. Hang on. Okay, so now you want to go ahead and outline the lateral face. I'm going to use pink to do that here. So I'm going to outline it just like this. Now I'm outlining this one, but I'm actually going to end up outlining 2. The reason I'm outlining 2 of them is because I really needed this front one here because of this height. That's the height of my triangle, and that's the base of my triangle. So you want to go ahead and list that there. So now I'm going to put the formula for area of a triangle underneath my triangle outline here, and I've written area equals base times height divided by 2. Then I'm going to plug in the correct information. Area equals 16 times 12 divided by 2. Then we want to cross simplify. So I'm just going to cross simplify the 2 and the 16, and I get 12 and 8. And now I get an area of 96. Now when I put a box around this, I realized that I probably should have come back here and counted this face. So remember, the base is only going to account for 1 of your surface areas, or of the areas of each surface. So now your, excuse me, the 96 will count for face 2, 3, 4, and 5. Because remember, for each side of your rectangle, or actually in this case it was a square, you are going to have a triangular face as well, which is called the lateral face. So now we want to add those up to find the surface area. So off to the side, you can see where I've added 256 plus 96 plus 96 plus 96 plus 96. Now, once you get good at this, you can also go ahead and multiply 96 times 4 and just add that to 256. That will be fine. So as you can see, you get 640 for a surface area. But before I'm going to write it on the line over here, I'm going to write surface area equals 640 feet squared. Don't forget, it's square feet because you're talking about area. It's not feet cubed. Feet cubed would be how much space is inside. So that's why it's square feet. All right, welcome back. So now, as you can see, I went ahead and outlined the base in green, and I have identified that it's a square because the two side lengths are 3 and 3. Then I'm going to use my formula area equals side squared, plug in the 3, and I get that the area of my base is going to be equal to 9. Then I'm going to put a pink outline around the triangular face, which is one of my lateral faces, and the base is 3, and the height is identified as being 4.5. So then I'm going to use my formula, area equals base times height divided by 2. Some of you on the test I'm still seeing are not dividing by 2. This is a major mistake that you cannot still be making at this point. You have to know the formulas. They should be memorized, but they were still given to you on the test, and some of you still made that error on every single triangular problem. So now you want to go ahead and plug in 3 times 4.5 divided by 2. Whenever none of the numbers on top are even, I just go ahead and multiply the top out, and then I divide it by 2. So you can see that I've done that here, and I get an area that is going to be equal to 6.75. So I'm going to put a box around that, and I'm also going to label that with faces 2, 3, 4, and 5. From there, I'm going to go ahead and add my surface areas. Once again, you're adding a decimal, or several decimals rather, to a whole number, so you need to make sure to line your decimals up properly. From there, you want to go ahead and add, and you get a total of 36.00, which is actually a total surface area of 36 inches squared. So double check to make sure all of your work matches up and your answer is the same, and then we can move on. All right, so now you should be looking at textbook page 785. On textbook page 785, you'll see the surface area of pyramids with triangular bases. A triangular pyramid has one triangular base and 3 triangular faces. So I'm going to go ahead and put a box around the one triangular base and 3 triangular faces. And that makes sense that a triangular pyramid would have 3 triangular faces because a triangle, since the triangle is its base, a triangle only has 3 sides. So that's why it would have 3 faces as opposed to 4 when you have a square or a rectangular base. If the base is an equilateral triangle, remember that word equilateral means all sides are the same, all 3 lateral faces are congruent. So congruent means the same size and shape. If the sides of the base triangle are different lengths, the areas of the lateral faces will also vary. So that can be a more complicated problem, kind of like with the the triangular prisms when you have a non-equilateral triangle. All right, so now let's go ahead and look at example 2. Example 2 says to find the surface area of the pyramid. Find the area of each face and then add. The triangular base is an equilateral triangle. Go ahead and underline that because all 3 sides are 4 feet long. So now we just want to go ahead and first identify our base and find the area for that one. Notice that I drew the triangle kind of pointing to the right, and the reason I did that is because the triangle on my base is pointing to the right. So you need to make sure to take a look at whatever triangle you're drawing for the base so that you can make an accurate description. That's important so that you have the accurate base of that triangular base. So we're talking about the base of the base now. So now I want to go ahead and label it. As you can see, the height of the base, if you go ahead and look very close right here, I'm going to outline it in yellow, is right here, and there's a black line extending out. So the height of the base of the triangular base is 3.5. So you want to list that out to the side. First, you can draw the little line in your triangle, 3.5, and then you want to make sure that you identify that as being the height. And then the base of your triangle is right here. Again, we're talking about the base of the triangular base. So that's going to be 4 feet. So now you want to go ahead and label that here as 4 feet. Then you'll use your formula for area of base to go ahead and work through that problem. As you can see, I get an area of 7 because we cross simplify the 2 and the 4, and we get 2 times 3.5, which will give us 7. And again, as the problem stated, since it is an equilateral triangle, you can tell that. I'm going to go ahead and erase what I've drawn over the picture here. But you can tell that this is an equilateral triangle because you have the base here of 4, you have this as 4, and you know this is 4. So that's how you know that it's equilateral, because all 3 sides of the triangle are 4. But keep in mind, notice that we did not put a height of 4. The height of the triangular base is not 4, it's 3.5. What makes it equilateral is that all 3 sides are 4. It has nothing to do with the height of the triangle. So now we need to find out what the lateral faces, what the area of the lateral faces are. So let's go ahead and look at one of the lateral faces. You can see the lateral face that's right in front here, and it's outlined. I'm going to be outlining it in pink. So you can see that it has a base of 4, and then you can also see that the height is outlined right here, and that there's a line showing you that the height is 5. So you want to go ahead and plug that into your formula for the lateral faces, and remember, since it's an equilateral triangle, all 3 faces are going to have the same area. As you can see, we found that you have an area of 10 for each one of the lateral faces. And remember, you just want to think to yourself, what is the shape of my base? The shape of the base is a triangle. Triangles only have 3 sides, so that's why you only have 3 triangular lateral faces. So now you want to find the surface area, you want to add the 7 and then 3 of the 10s. So as you can see, the final surface area for this problem is going to be 37 feet squared. Don't forget, it's feet squared, not feet cubed or just feet, because you're talking about area. All right, welcome back. So as you can see, let's go ahead and work on our base first. The base of this triangular pyramid is going to be outlined here in yellow. And as you can see, you have a side length of 2, another side length of 2, and another side length of 2. So again, we have an equilateral triangle on the bottom, so let's go ahead and find the area there. You also notice that the height is going to be right here, that 1.7. So let's go ahead and put that into our formula. So as you can see, I went ahead and found the area of the triangular base of our pyramid, which is going to be 1.7. And now we need to go ahead and look at our lateral faces. And again, since the base is a triangle, that means we're going to have 3 lateral faces. So I'm going to erase the work we've done here so far. I'm going to change my pen color to pink, and then we're going to go ahead and take a look at these lateral faces. So you can see me here. I have went ahead and outlined now in pink one of the lateral faces. I know it's not a perfect outline. Dot, dot, dot for the center. Ooh, that's wiggly. But notice the height of our lateral face is going to be 3.5. And the base of our triangle, again, of the lateral face triangle, is going to be 2 centimeters. So we're going to go ahead and put that into our formula for the lateral faces. So as you can see, I went ahead and drew my little makeshift triangle here with a base of 2 and a height of my lateral face of 3.5. Then I plugged it into the formula area equals base times height divided by 2 because it is a triangle. Then we're going to cross simplify these 2's, those become 1's, and you're left with an area of 3.5. Now remember, I put a box around that, and then I call that my face 2, face 3, and face 4, because remember, once again, this is a triangular pyramid, so you only have 3 lateral faces. So now to calculate the surface area, we're just going to go ahead and add all of these up, making sure to line up our decimals. So as you can see, I took the 1.7 from the base, and since that only accounts for 1 of the faces, I went ahead and put a check there. And then I have 3 that are at 3.5. So 3.5, 3.5, and 3.5. So now I'm just going to add those up, and I get my final answer, which is going to be 12.2. So I find out that the surface area is going to be 12.2 centimeters squared. And that should be written right there on the line for C. Let's go ahead and take a look at D. As you can see, I went ahead and identified my base of my triangular pyramid. And I went ahead and outlined it here in yellow for you so that you could see, you want to see our height of 5.2, and we have the base of our triangle, which is 6. So let's go ahead and plug that into our formula. As you can see, I went ahead and plugged that in, and now I'm left with area equals 3 times 5.2. So I'm going to get my final answer for this base of 15.6. I'm going to put a box around it, and I'm going to remind myself that that accounts for 1 of my faces. That is the base, of course, of the triangular pyramid. Now I'm going to erase my yellow outline. You don't need to erase yours. You just want to make sure that you're able to follow along with me here. And we're going to identify that lateral face. So let's go ahead and outline that now in pink. Again, here's our triangle, and we've got way, way tall up there. and we have this height right here. So this is going to be the height of our lateral face, the 8.3, and the base height of our triangle is going to be 6. So again, we have a base and a height of our lateral face as well. So let's go ahead and plug that in. As you can see, I went ahead and plugged in 6 for my base times 8.3, and then I divided it by 2. Now I'm going to cross simplify, so I get 1 on the bottom and I get 3 on the top. So now my area is going to be equal to 3 times 8.3. So now I get an area for one of the lateral faces of 24.9. And I just want to make sure in my brain this was an equilateral triangular pyramid base. So that means that we have face 2, face 3, and face 4 here. Remember, there are only 3 total faces that are triangular lateral faces, and then you have 1 base. And that's because a triangle has 3 sides. So now we're going to find the surface area by adding those up. So as you can see, I went ahead and added 15.6 because that was the area of my triangular base. Make that look like a 6. And then we're going to go ahead and add 24.9 3 times. And as you can see, when we add them all up, we get a final surface area. So our final surface area is going to be 90.3, and then it's meters squared. Don't forget it's meters squared, not meters cubed, or just meters. It's meters squared. So it's 90.3 meters squared. So hopefully you have checked your work here and made sure that everything looks like this. If your work was different or if you got the answer wrong, you need to make sure that your work looks just like this. Make sure you're correcting it. Okay, and as usual, when we work through these longer sections, I'm just going to verbally go over this example 3 with you because there's not a whole lot of new information here. It says a pyramid puzzle has all sides that are equilateral triangles. Each triangle has side lengths of 8 centimeters. The slant height is 6.9 centimeters. So the only thing that's different here is just the slant height, and it's 6.9. So find the surface area of the puzzle. So you just have a bunch of triangles here, and what you really need to see is that you've got 1, 2, 3. Now your base here is going to be, they said it was an equilateral triangle, so it's going to be 8, 8, 8, and then you have a height of 6.9. So then you get, when you plug it into the formula, you get this 27.6 square centimeters. So the surface area of the puzzle is 4 because you have 1 face here, 2, 3, and 4. So notice how you have 1, 2, 3, 4. So you take that answer of 27.6 and multiply it by 4. Then you get the final answer here of 110.4 centimeters squared, or square centimeters. So that's all I'm really going to do on that slide. So now we're going to go ahead and look at textbook page 786. I know we did the class lesson today, so everything's a little bit turned around, but that's okay. For homework tonight, I need you to do textbook page 786, numbers 1 through 4. And then in addition, I asked you to go ahead and do textbook page 787, and this is only for my advanced class, 787, and that's going to be all those problems on that page. So 787 will be collected when you get to class tomorrow. So good luck, and I look forward to seeing you then.